So for our warm-up, we're going to go to y equals, and if you already have this graph, then great. We're going to plug it in, and we're going to see if we get the same thing on our calculator. So my equation is what? -3 times the absolute value of x plus 1. So I'm going to go -3. Absolute value is under math, number, abs. Okay? So if your calculator is kind of fancy, you're going to get these absolute value bars. If not, I mean, you know, it is fine. It'll say abs and parentheses. That's fine. Same thing. So then we'll put x plus 1. X is right here next to the green alpha button. All right? And then close the parentheses. If you have abs, open parentheses, then close the parentheses where your bars end. Okay? All right. So then we're going to graph it. And if your graph doesn't look like mine, right? I put in the right. Yes, push the graph button. If your graph is kind of weird and wonky, you can go to Zoom 6. All right? If your graph looks funny, go to Zoom 6. Yeah, that's good. 6. So Zoom standard. All right. So if your graph looks like this, great. Because what should it have done? Reflect and left 1, right? From 0, 0, your parent function. Okay. To get these points and to make sure that we, you know, graphed our function, we're going to go to second graph. And then we get the table. All right? Then that way they have all of these points here for you. And then you can graph it. Okay? And you know what? Absolute value, since it's symmetrical, right? It's pretty nice when you go on the graph, when you go in the table, you can see where the vertex is because look at your y numbers. From 0, what does it do? -3, -6, -9, right? Yeah, but they're like the same. Well, your vertex is -1, 0. That's kind of like the middle where the numbers kind of repeat themselves on both sides, right? So, okay, so then with this, we said, okay, it is at -1, 0. And then I can go and get some points, right? -2, -3. And then this, right? And we're going down. Oh my goodness, sorry. Listen. Oh. Sorry. My lines aren't. Okay. So, domain. All right, domain is from left to right. Yes? We said that we want to look at this graph from the left to the right, and you have to tell me where my graph exists. The good thing is that, guys, if we have an arrow going to the left, that means we're going to the left forever and ever and ever. Where are we going? Yeah, negative infinity, right? Parentheses, because infinities always get parentheses. And then look on the right side. Oh, arrow on the right. That means we're going to the right forever and ever. Where are we going? Infinity. Yeah. So the domain for absolute value is all real numbers. Did any of you guys notice that your domain for absolute value is always all real numbers, regardless of the transformations? Because you have an arrow on both sides? Huh. Right? I don't know. Go back and look. Go back and look. Seriously, you'll see. I mean, you know, look for those kind of patterns. So then look at your range. Range is looking at this graph from the bottom to the top. from the bottom, meaning negative infinity, all the way up to positive infinity. You're telling us where this graph exists. So if I have these arrows that are going straight down, goodness, where are they going?
Negative infinity.
Negative infinity. Okay, so it's going from negative infinity, and we're coming up, up, up. Does my graph stop here? No, it keeps going until we get to what? To -1? Remember, we're talking about y numbers.
0.
0. Okay? 0. And this gets a bracket because that is a closed circle on that point. Yeah.
How do you find the other coordinates that you're going to plot, but without these?
Okay. All right. I'll show you. So then, you know what? Let's go and find the vertex. Okay? So, you know, a shortcut to finding the vertex, all right? If you look at your function, right, you can get the vertex by doing opposite your h number, comma, whatever your k number is, okay? And you know this from transformations. H is the number that's inside with the x, okay? Give me the opposite of it.
-1.
-1. And what is my k number? What number is being added or subtracted out here?
Nothing.
Nothing, so what is it? 0. Yeah? So there's our vertex. Okay. So Isaiah said, how do you figure it out if you don't want to use a calculator? All right, find your vertex. Your vertex goes in the middle, right? Since this has a 3 in the front, right, and a negative, I know that it reflects and it stretches. Okay? That 3 is your slope. Think of absolute value as like 2 lines here. Okay? Each of these lines has a slope of 3. 3 means it's rise over run. Do you agree? All right. So I know starting at my vertex, I'll use a different color right here, I have to go down because it reflects, and up 3 or down 3, I guess, and then right 1 or left 1, right? So down 1, 2, 3, left 1. Down 1, 2, 3, right 1. Remember, absolute value is symmetrical, right?
Yeah.
So if I'm going left 1, I also have to go right 1. Yeah?
So what if, say there's like an example where there isn't a number in front of the absolute value sign, so it's like just like negative. would that
Then
be
it's just
negative?
down 1, left 1, or down 1, right 1. If there is no number here, guys, the slope is 1. Up 1, right 1, up 1, left 1, or down 1, right 1, down 1, left 1. Yeah.
Can we just put the x into it and solve that?
Yeah, you can do that too. You can put in a number for x. Since you know that your vertex is at -1, 0, I mean, you could do, okay, well then I want to do -2 and -3. Or 0 and 1. You can do that. And plug it in, solve it, see what you get for your y. That's another way. I mean, that's the fun part of math, is that you have so many different ways, right? You pick and choose what you like. Okay, so there's your vertex. Where is the axis of symmetry? Huh?
-1. X equals -1.
Thank you. X equals -1. Guys, it's in the name right here. X is. And, you know, if this graph is symmetrical right down the vertex, then isn't it just the x number from your vertex? Yeah, x equals -1, right? There you go. There's your -1, right? Okay. Well then, you know what? The axis of symmetry is so great because then it helps us to set up for the increasing and decreasing intervals, right? This is where the graph changed direction. That's where the axis of symmetry is. It's at -1, x number, right? You have an arrow on the left, so that's going to -infinity. We said that. You have an arrow on the right, so that's going to infinity. Do you agree? Okay. So now why don't we look at the graph and talk about whether it's increasing or decreasing. Since this is going all the way down here, if I start from the left, this graph is going how?
Increasing.
It's increasing. Oh, I'll write it here. Increasing. Yeah? From negative infinity to negative 1. What is it doing from negative 1 to infinity? It's decreasing. Okay? So it's increasing from negative infinity to negative 1. And remember, increasing, decreasing, and constant, you always use parentheses. Yes? Okay? And it's decreasing from where to where?
-1 to infinity.
Good. So, think about absolute value graphs. You're only going to have that one axis of symmetry where it changes direction, right? And we said the domain is always from negative infinity to infinity, right? So you're increasing and decreasing for these guys so much easier than the wacky graphs that we had before, right? You're always going to be going from negative infinity to your axis of symmetry, and then from your axis of symmetry to positive infinity, right? You just have to decide, is it increasing or decreasing? Yeah? Okay. So how about these guys? Oh my goodness, what does that mean? That as x approaches infinity, f of x approaches what? These are the end behaviors, right? The arrows, your arms of your graph. How are they going? Up, down, or straight? So as x approaches negative infinity, just imagine if you're walking on the x-axis and you want to go towards negative infinity. Which way do you have to go? Huh? To the left. Yeah. So this one is asking you about the left arm. Oh my gosh, I erased everything, didn't I? I mean, it shouldn't have been. That was pretty reckless of me. Excuse me. There. Okay. Yeah? So your left arm, where's that going?
Negative infinity.
Yeah, to negative infinity because it's going down, right? And then think about the other arm. As x approaches infinity, if you're walking on the x-axis and you want to go towards infinity, which way do you have to go? To the right. So it's saying all of your, as your x numbers are going towards infinity, what is your function doing? Infinity? So it's going up?
No, negative.
Negative infinity, right? And think about absolute values. Absolute values are sharp V, right? If one's going up, can the other one be going down? No, they're always going to be doing the same thing, right? Even if you flip it, if one's going down, the other one's going down, right? So your end behavior should always be the same. All right, any questions on this? Okay, so let's go over the homework. And we'll go through some examples. That's pretty much everything for today. Everything you need to understand. And now we will formalize it. So, if I want to create formal rules, whenever we need to graph inequality like this, y is more than f of x, or y is more or equal f of x, or we can do the less than also, right? Whenever I have an inequality like this and I need to graph it, I first need to decide whether or not I will use dotted or solid line. So when do I use dotted? When do I use dotted? So it's when I have either that or that, right? Less than or more than. When do I use solid?
Less than or equal to, greater than.
Whenever I have the inequality with or equal to. And then the second step is to actually graph it. We can graph it manually as we did before, or we can graph it using the calculator. Doesn't matter. And make sure that whenever you enter it into calculator, it's always the equality, the equation, right? So you always graph equation, not inequality. Right? So I enter
for this one, I would graph y equals 10. And then I just need to use the dotted versus solid. And then we shade. If the inequality says greater than or greater or equal to, then I shade where? Above the line. And if the inequality says less than or equal to, I shade below. That's it. That's all for today. And now we just go through examples. Okay? So let's do that. The first example. Oh no, one more thing. So if somebody asks you about particular point and you need to figure out whether the point is the solution or not the solution. So if my point is in the shaded area, is it the solution or not?
Yes.
Yes, right? It is a solution. That's what we decided, right? Shaded means solution is good. We want it. And if the point is not in the shaded area, is it solution or not?
No.
It is not a solution. What about if we are asked about the point that is right on the line? How do we decide? If a point is on a dotted line, is it a solution?
Yes.
If it's the dotted line, right? We don't want the line. It means that we don't want to include the line because we don't have this equality here, right? It means that it's not a solution. And if the point is on a solid line, it's the solution? Huh? Yes. Questions so far? David? Questions? Okay, so now let's go through some examples. Okay, first example. So we need to graph this inequality. Y is more than absolute value of x minus 2 plus 1. Will we have dotted or solid line? Dotted. Okay. Then we need to graph. What do we graph? What do we actually graph? The equation, right? We first graph the equation. So y equals x minus 2 plus 1. That is what I want to graph. Right? So I can do this by using my calculator, or I can do this by using my transformations, whatever is easier. Right? Whatever you want, you can do. I'll just do the transformation. So I know my parent function. I know that right 2 plus 1. And this one doesn't change. Oops, dotted line. And then I don't forget to use the dotted line, right? So even if you use the graph, it should look something like this at first, right? Because the transformation told me it's right 2 up 1. That's what I did. So then I shade above or below?
Above.
Above, very good. Because I have the inequality for greater than. Yes, that's what we wrote down, right? Did you write it? Okay, so now state the solution. This means just give me an example of one solution. Any solution. What is the solution to this inequality? From
3, 4.
So it's right 3, 4. It's in the shaded area, right? So it's a solution. 3, 4 is good. I mean, we could have chosen anything, right? Anything in the shaded area. What about something on the dotted line? Would that be good? No, it's not a solution. Very good. So is 2, 1 a solution?
No.
2, 1. Oh, it's exactly on that line, right? But the line is dotted, so no, it's not a solution. What about 0, 4?
Yes.
Yes, that's in the shaded area, so yes. Questions? Let's do one more. Well, actually these two. Let's work on these two. F is greater than minus 3, will we use the dotted or solid line?
Dotted.
Dot. Okay, so dotted line. How do we graph it? So that was first. Graph, always graph equation. So x equals minus 3. How do we graph it? Jaden, how do we graph this? X equals minus 3. What? Right, so what kind of line is this? Vertical, horizontal, or goes like... It is a vertical line, right? It goes through what point? Huh? X equals negative 3, right? So the line will go through minus 3, 0. Looks very similar to the formulas for our axis of symmetry, right? X equals minus 3. Right? So it's a vertical line. Okay, so where do we shade? What are the solutions? X is greater than minus 3. Where do you think we should shade?
The right.
On the right side. Very good. So this is everything. That is the solution. Very good. Because we want everything, all the points that have x coordinate greater than minus 3. Right? So everything on that side. So what about the next one? Y is less than or equal to minus 2. What is the first thing to do, John? Solid line. Good. Then we need to graph. What do we graph? Y equals minus 2. How do we graph it? Juvan. Horizontal line goes through which? Negative 2, right? 0, negative 2. And this is solid line. So this is my line. And how do I shade? Where do I shade? The bottom, right? Because it's less than. And we include the line, the actual line. Very good. Questions? No. Awesome. Let's do one more. Should we do it together, or do you want to do it by yourself? By yourself. Okay, let's try.
Button.
Button. Best.
All right, so number 4. Is this dotted or solid? So dotted. Okay, and then we have to graph it. Where's my vertex? Where's the vertex? 3, 0. Okay, so 1, 2, 3, 0. Where's my next point? Up. Huh? So, okay, up 1 over, what do you mean? To the left 1. Up 1 to the right 1.
Give the coordinates. That's why.
Okay, I'm gonna just trust that because when Sarah walked around, she saw your papers, right? You guys said dotted, so I'm gonna put dotted. Yeah? Is that good? So do we shade above or below? Okay, so above this vertex. Okay, so state a solution. Okay, 3, 3. Is 0, 0 solution?
No.
That one? No. Okay. Is 3, 0 solution?
No.
Oh, wow. Okay. All right.
I do it manually. What do I do with these, or with the parent function to get to this one?
We'll set 1.
Hmm?
So up 1, right 2.
Up 1, left 2, and then I stretch it, right? So up 1, left 2, and then I need to do the slope. Change the slope from 1 to 2. Looks good?
You're stretching out.
Mm-hmm. When I stretch or compress, what does change? The slope, right? The slope changes. The parent function, if I use here the green one for the parent function. What is the slope of my parent function? The green one. The slope here is 1, right, or minus 1, because it's 1 over 1. And for the new one, it's 2 over 1, right? Rise 2 for run 1. Right, so if I stretch it, the slope becomes steeper. If I compress it, the slope will become flatter or not as steep, right? So let me remove that. Are you good? You can always check yourself with calculator. Graph it and then compare. Ah, shade, the buffer below. Below, very good. Everything here is shaded. State a solution. Negative 1, negative 1. Everyone agrees? Negative 1, negative 1. Yes. 0, 0. Is it a solution? Sure. Right here in the shaded area. Yes. What about minus 1, 3? So minus 1, 3. Where is it? On the line. What kind of line? Solid. Is it a solution? Yes, it is a solution. Questions? So let's do something with like bad numbers. Something not very pretty. Well, let's do this one.
Is that what is that pretty number?
Is it pretty?
No.
It's too pretty, right? Some minuses, some fractions. Okay, so dotted or solid? Or do you want to do it by yourself? Let's do it by yourself. No? Okay, so dotted or solid, David? Dotted. What do I graph, David? What do I graph?
That's why.
I just graph the same thing but with the equality sign, right? So this is what I need to either enter into my calculator or know what I'm doing, right? Okay, so what transformations from parent function? Just because I don't like calculators very much. Compress by 3, then what? What about this 0? Oh, I mean, reflect, compress, and then what about this 4? Up 4. So I reflect, I compress, and up 4. Should look something like that. Looks good? I thought. If anyone used calculator, does this look right?
Yes.
Yes.
Yes. Shade. Where do I shade, David?
Underneath.
David, where do I shade? Below, because you have the less than. State a solution. David, let's state a solution. One of my solutions, David, somewhere in the shaded area.
0, 1.
0, 1 is the solution. This one. It's in the shaded area. Choose the following points that are solutions to each inequality. Choose all that apply. Is 3, 2 solution? David?
Yeah.
Yes. It's still in the shaded area. 3, 2, under the line. What about 0, 4?
No.
Yeah. It's on.
No, it's on the dotted.
It's on this line, but what kind of line is it? Dotted line, not a solution. Dotted line, not a solution. What about minus 4, minus 2? Yes, right? Minus 4, minus 2, everything below is good. 6, 2?
No.
No. 6. 1, 2, 3, 4, 5, 6. 2. No, very good. 4, 5? Questions?
No.
I think you should do one more by yourself. We have time for that. So let's do that.